In this lesson, we're going to talk about finding the integral of sine natural log of x dx. So how can we do this? Well, first, we need to start with u substitution. We're going to say u is equal to ln x. Now, if we do that, that means e to the u is equal to e raised to the ln x. If we put u equals ln x on the exponents of e. Now, e to the ln x, because the base of e and the base of natural log are the same, e to the ln x is simply equal to x. Now, if x is equal to e to the u, dx is going to be the derivative of e to the u, which is e to the u times du. So what we're going to do right now is replace the natural log of x with the u variable, and we're going to replace dx with edu, which is just this part. So this will give us the integral of sine u times e to the u du. Now, in order to integrate this expression, which I'm going to write it like this, we need to use integration by parts, and we're going to have to do it 2 times. Now, in that formula, it's the integral of u dv, which is uv minus the integral of v du. Because I don't want to write u twice, I don't want to confuse it with this u, I'm going to change the letters of that formula. So let's say the integral of a db, that's going to be ab minus the integral of b dA. So just before it was u dv, and this is u times v minus the integral of v du. So everywhere we saw a u, we replaced it with an a. And everywhere there was a v, it was replaced with b. So we're going to make a equal to e to the u. So that means that dA is going to be e to the u du. And then we're going to make dB equal to sine u du. So b is the integral of sine, which is negative cosine. So using the formula, it's going to be a times b, which is e to the u times negative cosine of u, minus the integral of b, which is negative cosine, times dA, so that's e to the u du. Now we're going to have to use integration by parts on this expression. But first, let's rewrite it. So this is the negative e to the u cosine u, and then the 2 negative signs will cancel, so plus integral e to the u cosine u. So let me get rid of this. So we're going to use the same letters. I'm going to make a equal to e to the u again. So dA is going to be e to the u du. Now dB is going to be cosine of u du, and b, the integral of cosine, is going to be sine u. So just this part right here, let's focus on that. So this part is going to stay the same, and then it's going to be AB, so that's going to be plus AB. A is e to the u, b is sine u, and then minus the integral of b dA. So b is sine u, and dA is e to the u du. So this is equal to what we have here. Notice that these two terms are similar. So what I'm going to do is I'm going to add this integral to both sides of the equation. So doing that, I'm going to have 2 times the integral of e to the u sine u du on the left side. These two will cancel. And on the right side, I'm going to write this one first because it's positive. E to the u sine u, and then minus e to the u cosine u. So now I'm going to multiply both sides by a half because this needs to be a 1. And so the integral of e to the u sine u du is going to be 1/2, and I'm going to factor out e to the u. Actually, I'm going to leave it like that. So 1/2 e to the u sine u minus e to the u cosine u, and then plus c. So now what I'm going to do is I'm going to apply this. I'm going to replace u with ln x. So this term turns back into this. So instead of e to the u, it's going to be e to the ln x. And instead of sine u, it's going to be sine ln x. And du is 1/x dx. So that's going to be, if you replace du, this is 1/x dx. On the right, we have 1/2, and then e to the ln x, sine ln x, minus e to the ln x, cosine ln x, and then plus c. So e to the ln x, we said that's equal to x. So this becomes x sine ln x times 1/x dx. And x and ln x, they will cancel, giving us back the original expression. On the right side, everywhere you see e to the ln x, that's going to be x. So it's x sine ln x minus x cosine ln x plus c. So I'm going to factor out the x as well. So our final answer, the integral of sine ln x dx, is going to be 1/2 x times sine ln x minus cosine ln x plus c. And so this is it.